Fantastic. Afternoon, everyone. I was just saying how strange it is to be back in front of people again. I dug out my trusty wireless presenter mouse 8000, which I can recommend, except that I dug it out yesterday, it didn't work. It took me the best part of 2 hours to get the thing working, and it's still a bit flaky. I mean, it's not the hardware, it's the things I had to install. So if this presentation suddenly disappears, I've pressed the wrong button on my presenter mouse, and normal service will resume, hopefully. Welcome. It was really nice to be back talking to people again and not sitting on the end of a camera. I'm Mike Ormond. I work here at Microsoft. I'm in our partner team. And I'm here to talk about DevOps and GitHub. My job is a cloud solution architect aligned to what we call digital and application innovation, which to any normal person would be application development and innovating on the platform, essentially. So what I plan to talk about is what we think of as DevOps at Microsoft, what we do as far as DevOps is concerned within our engineering teams at Microsoft. And I'm not a member of the engineering team, so I can only talk to you about as I understand it. A little bit about the fact that we do have 2 DevOps tools in Azure DevOps and GitHub, and kind of how we see those things together and the benefits of having those 2 investments, if you like. And then I'll do some demos at the end, primarily around kind of innovation on the platform. So it's not going to be, work items and actions and things. It's going to be a bit of hopefully the more interesting and exciting stuff that we see happening, particularly on the GitHub platform. So let's start with what is DevOps. So we have a very long history at Microsoft with development tools, development platform, and even with DevOps and source control systems. When I started at Microsoft, which is a very long time ago, we had this thing called Visual Source Safe. That may have been supported out of one of the teams I was in at the time. But we had a thing called Visual Source Safe, which predated any of this DevOps malarkey. I was going to say a much maligned product, probably with good reason. It wasn't exactly the most resilient and reliable of products. But and this is obviously with a kind of Microsoft lens on it, but around 2006 we launched this thing called Team Foundation Server, which is the predecessor to our cloud DevOps project. It's gone through a variety of different names over the years, but that was basically the on-premise, install it on your server, and you've got yourself a source control system, application lifecycle management system. 2008, GitHub launches. Probably wasn't on our radar back then, but certainly was on our radar 10 or so more years later. In 2009, an interesting thing happened. There were some architects from Flickr turned up at a conference, I think it was in San Francisco, and talked about what really is the kind of predecessor to what we think about as a big part of DevOps today. So most people were building software, putting it onto CDs, shipping it to customers, who then installed it and were responsible for running it. These folks from Flickr turned up and talked about how they were deploying 10 or more times a day into their production service. And that was really quite a radical, you can imagine how radical a notion it was back in 2009. 2010, AWS, Azure, a bit later kind of GCP started to take off, but we saw this explosion in public cloud providers and those types of services. 2010 as well, moving from continuous integration and just the building of software into the deployment, kind of picking up from where those the seeds that had been sown at the conference with Flickr. Continuous deployment started to become a reality. Security came in around 2012. People started to think, how does this impact from a security perspective? 2013, infrastructure as code, and the idea that actually having a repository and having a repeatable mechanism to deploy your services as well as your application was just as important, and maybe we could do that with DevOps. 2014, site reliability engineering became a career as we moved from shipping software to customers who were responsible for running it, to a scenario where actually we're kind of not only building the software, we're running it and it's a service and we're responsible for the uptime of that solution. 2015, machine learning started to become more ubiquitous and built into products, and we'll talk about that a little bit later on in the demo. 2017, containerization, cloud native, Kubernetes is a big part of this whole kind of overall movement, and then here we are now. So from a Microsoft perspective, the definition that we would typically use is that it is the combination of people, processes, and technologies to deliver continuous value to users, and that last bit is really quite important. So the focus is on how do we continually improve and how do we measure the value that we are delivering to users. And this is kind of a weird, well, for me, this is kind of a weird session to do because I normally talk about technology and you can kind of get your arms around it. Technology is only a relatively small part of DevOps. Much more DevOps is about people and it's about the processes. And yes, we've got tools that can help to do it, but the tools are nothing without those other parts. And actually, people is probably the most difficult part of DevOps because you are basically pushing against an established norm if you're trying to take an organization and move it to a more DevOps-focused organization. And you're pushing against an established norm that works because this organization has been building software and it's been successful. And obviously, it's a difficult proposition to say, actually, we need to do it radically differently, and we need to do it in this fashion. So it's something where it's a big change management exercise. You need to take people with you, and everybody from product managers, devs, testers, management, all need to be behind this change if it's going to be in any way successful. So why is DevOps important? Why do we think DevOps is important? There's lots of reasons, but one of the reasons is just the sheer level of disruption we are seeing in the industry today. So whether you look at financial services and the challenger banks and banks with no high street presence, sometimes just a mobile presence, whether you look at energy providers and the kind of increasingly radical tariffs that we see to take advantage of all sorts of different factors, but EVs is a big part of it, being able to charge. I charge my EV through the night because I get it super cheap through the night. Even kind of traditionally more conservative industries like healthcare, we see virtual appointments have become the norm as a result of the pandemic, but even the use of IoT devices to track people's health and monitor them and their recovery, etc., it's becoming much more prevalent. So that leads us to a place where this kind of level of ubiquity in the market, if you like, this explosion means that organizations that build software have to be much more agile to address the expectations and demands of the customers that are using those solutions. So we see kind of the app of the future as taking advantage of cloud native. Of course we would. We are a cloud provider after all, but the flexibility, the scalability, the economy of scale of building on cloud and building applications that aren't just lift and shifted to cloud, but take advantage of those capabilities is a real differentiator. Intelligent applications, and I mean that not just as applications that use the data they collect intelligently, but the organization that owns those applications using the metadata about that application to understand how to target users, how to retain users better, and all that data becomes a hugely important part of the picture. Building on the foundations of others' work, that's not really anything radically new. It's highly unlikely that you are building solutions today where 100% of the source code is written by yourselves. So, the use of frameworks, the use of open source software, not unusual, but increasingly we'll see the use of inner sourcing within organizations where that economy of scale of reusing code that's been used between silos, across silos, becomes increasingly common. And as I mentioned, really, this is about customer expectations and the changes that we've seen, and the ability for challengers to enter a market which would otherwise have been, been shut off to them because of some of the kind of innovations we've seen around cloud and the kind of geographical distribution, where challengers now from the other side of the world can come and enter markets that would otherwise have been closed to them. So I'll talk a little bit about Microsoft and our DevOps journey, and it very much is a journey that we're on. I am not standing up here saying that we know how to do DevOps. that we've got all the answers. It's a long journey. It's a journey in which we've made many mistakes, I am sure. It's had pain along the way. But some of the things we've learned, I think, on that journey is what I'd like to talk about, and some of the things we do to try and address those things. So one of the things we talk about at Microsoft a lot, and this isn't just a DevOps thing, is adopting a growth mindset. It's very much something that Satya talks about a lot. What that means really is looking for continual improvement and changing the way that you view failure as being an opportunity to do it differently next time. So certainly on that DevOps journey, looking for ways to improve, relying on the collective rather than heroic individuals, a shift in that kind of embracing diversity and trying to create these teams that work well together has been a big part of that endeavor. Creating a culture of customer obsession. I'll talk a little bit more about this later. As somebody outside of the engineering groups, I can see the journey, and I think that's probably one of the kind of longer journeys that we've been on. It's very easy as a large organisation such as Microsoft to become a bit insulated from this, but there's been a dramatic change over the last few years. And aligning behind a set of shared objectives. So that doesn't really mean anything in itself, but one of the things that characterized the engineering organization at Microsoft some years ago was a very distinct stovepiping between the divisions. You may have seen the memes online on the way the divisions kind of viewed each other. But there's been a big shift to create a sort of collective community around engineering excellence and a common engineering platform, and sort of bring those organizations together so there's much more commonality and sharing across those engineering divisions than there has been historically, which again brings us some economies of scale. And we do things at a very large scale. This slide is probably a year or two out of date, so I imagine these numbers would be even higher today. We have over 100,000 engineers are using the DevOps platform inside Microsoft. What have we got? 500 million test executions per day, 5 million work items being viewed per day, 85,000 deployments. So that's not 85,000 deployments into production, but it's 85,000 deployments through the DevOps platform that we use. And the way we kind of view this investment in automation is about creating space for the engineering teams to innovate rather than spend time just keeping the lights on, keeping things running, making sure the systems are up. The fewer issues we see in production, and the less time those issues are allowed to persist, the fewer customers the impact. For less time, the less support issues we have, and the management of that. That all builds up to be a big kind of investment of energy that's not terribly productive. So we're trying to shift things to the left in that respect. One of the other things we talk about is automation. There's no such thing as partial automation. We insist that no command line scripts are copied and pasted out of Notepad or OneNote or emails or any of that. When you commit to automation, you do automation end to end. And for something on the scale of our cloud platform, that's an absolute necessity, because the way those things are rolled out, there has to be absolute repeatability and consistency as you roll out to the bigger rings and rings for the larger data centers. So some of the things we did, I talked a bit about shared objectives. Creating clarity was around using something called OKRs, objectives and key results. Objective is a kind of aspirational goal that you want to achieve, but isn't very measurable. So you have to create a set of measures that allow you to track progress against that goal and ultimately tell you when you've hit that goal. It's not distracting at all. Sorry. It's also super important to measure the right things. So moving away from things like number of lines of code, number of bugs in the backlog, to much more customer-focused measures like how long did it take us to detect there was an issue? How long did it take us to mitigate that issue? How long does it take us to deploy updates? Those types of things. The customer obsession, I mentioned this, you may have noticed that we have in many of our products now mechanisms allow you to proactively provide feedback. I just provided some in Outlook this morning, as it happens, because it's got a really annoying little feature. And also, every now and again, we have products that nag you to provide feedback. Sorry about that. Not unusual in the industry, but we are trying to connect the users of the products with the engineering teams at the back end. In forums, many forums, issues get propagated direct through into work items in our systems. And with some of our largest customers, very largest customers, there are engineers, representatives from the engineering team, so developers effectively sitting in aligned to those customers to really understand what the issues are that those customers face with our products, but also the pain that they endure when things don't go well, so that they can represent those back to the triages and to the bug bashes, etc., to prioritize those issues appropriately. So trying to just close that gap that's existed. The full stack teams, if you think about it, the way we, I talk about this historically as if it was many, many, many years ago. It's not that long ago. We kind of operated in a system where there's a meritocracy at Microsoft. You get rewarded for the impact you deliver, and developers were measured on what kind of innovations could they create and roll out on the product, and the ops people were rewarded for minimal downtime, stability, no change. There's a tension inevitably in that picture that has to be addressed. So it's now a case that these full stack teams are a blend of operations, engineering, product management, typically 12 to 14 people, and they will be responsible for a particular feature, and that feature from its inception through to deployment and ongoing operations of that feature. So they really own it end to end. I talked a little bit about the collaboration in terms of moving to a single underlying engineering system and establishing a kind of community of best practice across our engineering teams. The other thing you sort of have to consider is we want there to be enough autonomy within those 12 to 14 people teams to be able to do the right things, take the right decisions, take some risks, but we also don't want things to go off the rails. So there has to be some framework that they operate within, but we don't want to hamstring them. We want to see that innovation. We want to encourage and reward that innovation without damaging the underlying solution. And finally, building for resilience. I mean, we started to allude to that there. We came from an organization that shipped CDs in boxes, gave them to customers, and those customers were responsible for running that software, so the kind of operations sat with the customer. It's a big shift to move to an organization that delivers SaaS solutions, and we've got a long history of doing it, but not every part of the company moved at the same pace. So that build for resilience really kind of underpins now everything that we do. Yes, things go wrong. Things go wrong reasonably frequently. Some of those things are significant, some of things less so. But what we try and do is learn from each of those incidents and make sure that we put in place measures to prevent those things happening again. So that's Microsoft DevOps, Azure DevOps, and GitHub. You might have noticed we have these two things. There is some overlap between the two. Azure DevOps has been a kind of cornerstone of many enterprise development teams for decades now. And GitHub represents a really fantastic opportunity for us to kind of open the doors to this huge community of developers and kind of build the best of both worlds, learn from each side, and kind of bleed through the learnings from each of those two into the other. Now, quite how we position that with people who want to adopt these. Actually, out of interest, how many people are Azure DevOps users? Is that 50% maybe? How many people are GitHub users. I imagine there's some crossover. There'll be people that do both. Okay. You'll hear us talking about GitHub a lot. And the reason we talk about GitHub a lot is because as an enterprise solution, it doesn't yet compare with, actually, I don't know the numbers, but my presumption is it doesn't yet compare with Azure DevOps in terms of the kind of revenue it generates for this company. So we've got a very well-established product in Azure DevOps. It's very successful. It does very well. It's still on its path. But the reason you'll hear the GitHub voice louder than the Azure DevOps voice is that's mature. This is new in the enterprise space, so therefore we're shouting about how fantastic it is all the time. So all I'm saying is don't mistake that just because we're shouting about that doesn't mean that Azure DevOps is not important. It absolutely is, and it's an absolute cornerstone of our DevOps platform. So these two products come under a single leadership, so the decisions are made about Azure DevOps and GitHub are made from a single place. What you will see is that we are making a strategic investment in GitHub to leverage those kind of enterprise learnings that we have through Azure DevOps. So while Azure DevOps is absolutely alive, well, and will for many, many, many years to come, there's no suggestion of that product going away. Where you'll see the biggest changes and the biggest innovation is in GitHub, because Azure DevOps is quite a mature product. It does most of the things that we and our customers want it to do. But GitHub, there's lots of scope for us to make it more viable in the enterprise. And we're already seeing a lot of that happening. And these DevOps tools are now the standardized tooling that underpins the engineering functions at Microsoft. It wasn't always that way, but they are absolutely the things that we use to build the products that we build. So the question kind of becomes, and this is quite a difficult one because it depends on your purpose as well as what features you're looking for, which of these tools is perhaps better suited to the job today. And I stress today because GitHub is evolving quickly and some of these gaps will be narrowing and GitHub may overtake in some areas. But today, these are the kind of things that Azure DevOps is particularly good at. On the right, these are the sorts of things that GitHub is particularly good at from a kind of feature functionality perspective. But the thing I want to point out is it's not either or. It's designed not to be either or. You can take advantage of GitHub features in Azure DevOps and vice versa. You don't have to just pick one horse or the other. They are absolutely designed to work together. How are we doing for time? Not too bad. Okay. So what I'll do is do a quick kind of whiz through of some of the capabilities, the comparable capabilities in the two. I'm not going to spend any significant time talking about them, but just to give you an idea of the flavor of the features within these two tools. So from a planning perspective, Azure Boards and dashboarding and analytics in Azure DevOps is a very strong, capable feature for managing your projects from inception through the whole life cycle. GitHub Project Boards is a kind of lighter weight, simpler implementation of a Kanban, at least today. I have to preface all this with today. GitHub Project Boards is a simpler Kanban system. It's great for kind of lightweight management of projects and tying issues to work items and the like, but it doesn't have the kind of richness and the analytics that are present in the Azure DevOps implementation. From a kind of code perspective, developing things, many of you were probably in Liam's session prior to this, I imagine, and he will have waxed lyrical, I'm sure, about Visual Studio and what a capable tool Visual Studio is as an integrated development environment. It's been around for many, many years, particularly for an enterprise developer in the Windows space on .NET or C++ is kind of incomparable in terms of what it can do. But it's no longer the only game in town from a IDE perspective in Microsoft. We also have Visual Studio Code, which is our cross-platform, lightweight, kind of text-first, heavily plug-in oriented development environment. It's fantastic if you haven't tried it. It's particularly, if you're not in that .NET, even if you are in that .NET space, it's still fantastic. But if you're not in that .NET space, then it's got fantastic support for a wide range of frameworks, languages, all done through its plugin extensibility. You want to build ARM templates, you want to build Bicep. In my case, if you want to write a script for your MikroTik router, this is the place that will have a plugin for it to help you in doing that. It is a very cool piece of kit. It also has an online friend. So Visual Studio Code has Visual Studio Code Online. It is quite difficult to tell them apart. It is such a good, rich implementation of that desktop experience in the browser. It really is quite incredible. It's almost full fidelity, and that extension model is supported in the browser version as well. And then we've got some of the innovations in the kind of develop category, if you like. And I'm going to talk about these. I'm going to demo some of these later on. So I won't talk about them too much just now. Dev containers, fantastic for creating isolated, repeatable development environments on your desktop. Code Spaces is the kind of taking of that and doing it in the cloud. And Microsoft DevBox, which I was going to say we recently announced, but I think we recently GA'd. Is our kind of more Windows.NET development environment in the cloud. You can build a set of images for dev boxes, host them as a kind of a library in the cloud, and then folks can provision a new dev box and get exactly the configuration that's been created in that library. I'd have loved to have demoed DevBox, but I don't have access to it. Unfortunately, it's blocked on my tenant. But I'd have loved to have done a demo of Dev. That was as far as I got that little screen. And then, since I tried to provision one, it said you can't do that. But we'll have a look at the other two later on. From a CI/CD or kind of delivery perspective, we've got Azure Pipelines, GitHub Actions. They share a lot. There's a lot in common between those two. But Azure Pipelines remains kind of a bit more enterprise focused and can orchestrate across a range of different source control systems. GitHub Actions is tied into the kind of GitHub ecosystem. But it is a very flexible platform for automating things, which Azure Pipelines is very focused on CI/CD. I guess you could say what GitHub Actions can do more than that. Couple of examples of what that kind of abstract statement means. Ex-colleague of mine, fantastic guy, Jason, he built a GitHub action that will clean up your Azure subscription, or I'll clean up our Azure subscription. In my role, in his role, we tend to build a lot of stuff that we don't need to hang around for more than a few days or a week or two, perhaps. So he's built a GitHub action that you point it at your subscription, and it looks for things that are tagged with the word delete, either in a tag or in the name. And after 7 days, it just kills them. And that saves me an absolute headache of going back through and cleaning up my subscription. But it's nothing to do with CI/CD. Likewise, I've got a workflow, GitHub workflow set of actions that does a kind of, it's kind of CI/CD, but it's a bit unusual. I do a lot of stuff with our marketplace. Got a session this afternoon on marketplace. And when you deploy certain types of application from marketplace, the services get deployed, but the code is not really part of that. It's more of an Azure services deployment. So in my case, what happens is when the thing gets deployed, there's a webhook that gets called by marketplace to say, right, I'm done. And in my case, that triggers a logic app, which then goes on and triggers a GitHub workflow to take the outputs of that webhook, so I know where to deploy the code, and then trigger that workflow in order to deploy the code onto that newly deployed marketplace instance, which would be in a customer subscription. So it's kind of an unusual CI/CD use, but it's very, very flexible GitHub Actions. Hosting packages, containers and the like, we've got Azure Artifacts and GitHub packages. Azure Artifacts is kind of focused again around the enterprise space and particularly package management, creating and hosting your own packages and making them available via feeds, and kind of making public feeds available in a controlled fashion within your environment is kind of where Azure Artifacts plays. GitHub Packages is a kind of broader package management system, including support for, well, a wide variety of packages, including container images, and hosting that securely alongside your source code on GitHub. I talked about innovation in GitHub. One of the areas that GitHub is innovating very strongly, has a big focus on, is around security. Some of this stuff just you get for free, but without any control over it, without much control over it in your public GitHub repos. If you are an enterprise customer, you kind of get to configure this in the way that you want. But things like code scanning, looking for known vulnerability patterns within source code, secret scanning, so looking for connection strings, SAS tokens, those types of secrets within the repository, and dependency reviews and dependabot, so scanning dependencies in your solution, external dependencies, to look for any known vulnerabilities or vulnerabilities in the dependencies. So walking that tree and figuring out if there are known dependencies in that stack. Those are things that GitHub Advanced Security, and as I say, even GitHub public repos enjoy some of those things, like, for example, the secret scanning. And I think you do, yes, you get dependency reviews and dependabot on public repos as well. And then more broadly, kind of outside of the specific DevOps tools, a single pane of glass for security, protecting cloud, hybrid workloads, scoring posture, security recommendations, all that stuff within Microsoft Defender for cloud. Azure Monitor, App Insights, be well known to you, a single platform for monitoring the health and helping to debug application issues and site performance and all those types of things through those tools. And of course, not to forget that just we have a comprehensive cloud platform that allows you essentially to build anything you want. We have a huge range of different options when it comes to compute or storage or databases or whatever you choose to build. There will be a solution there in the platform for you. So, having talked a bit about kind of what's DevOps in Microsoft, and comparing the two platforms that we have, I just wanted to show you a few of what I think are the more innovative features that they're not intrinsically tied to GitHub necessarily, but they've kind of come out of that GitHub acquisition and the VS Code team in particular. So the first thing I wanted to look at was dev containers, because I'm a huge fan of dev containers. Essentially, in Visual Studio Code, I have a desktop application, but I can also have a component called the VS Code server that can run on a remote host somewhere. In my case, I'm often running the VS Code server in Windows Subsystem for Linux and VS Code in Windows, so that I can be building a project on the Linux platform and doing that in a Windows environment. Perfect. You can also deploy that VS Code server in a container environment, so it doesn't have to be in WSL. It could be in a container. And I can package around that, wrap around that, all the dependencies of my project. So I can have an isolated environment that I can connect to, build my software. It can be have a volume mount to my local file system. So I'm just building stuff that's on my file system, but I'm doing it within that containerized, isolated environment. I think it's incredibly cool. And also I have a definition that I can share with other people and they can get exactly the same environment as me. Now, I have done all these things as videos because the network up here has historically been patchy. So I'm going to try and talk over something I recorded a couple of weeks ago, which I've discovered is quite difficult. But we are in a repository that I will use throughout. So it's just a GitHub repository that I've pulled. And we're in that Marketplace Notifications webhook repository. I'm just going to start Visual Studio Code. And this particular repo has got a dev container defined. So when I start it up, I will be prompted in the bottom. I won't accept this, but I'll be prompted to reopen this thing inside a dev container. I'm going to dismiss that because we'll look at a couple of other things first. And I'll just prove to you that I've not got the dependencies installed. So I'm currently connected into my Windows subsystem for Linux here. And I'm just going to run a couple of commands to show that the dependencies are not installed. So this is a static web app solution. I should be able to run SWA to fire that up. I should be able to run func start to start the functions runtime, especially if I'm in the right folder. Sorry, even the errors are in there. So what I'm going to do now is the same thing as would have happened if I'd selected the reopening container. I come from the command line there. I can reopen this solution inside a container. It's going to spin up the container in the background for me. And you can see, well, two things. I'll do a Docker PS just so we can see. So Docker now is running that container. You can see the name of the repo there. Ooh, you can see the giant name of the repo there. And down the bottom left, you can see we're connected to that dev container rather than WSL. What we should be able to do now, I'm just going to point that out. What we should be able to do now, because this dev container has the dependencies installed, is we should be able to run SWA to fire up my static web app. And sure enough, that works, and I should be able to run my functions runtime as well. Although, as I say, I don't think I do it in the right folder, so I'll just fire it up in the right folder. So that dev container is now running on Docker on my Windows subsystem for Linux. But my Windows desktop VS Code is talking to that container so that none of those dependencies have been installed on my desktop, because I hate installing all sorts of things on my machine. So there's the functions runtime now running on that. We're all good and ready to go. Now you might wonder, if you haven't used dev containers, how many people have used dev containers? Not many. Oh, you are so missing out. What it takes to do this, because I had a pre-configured dev container there. So I've started an empty directory there. There's nothing in this folder. And I'm just going to spin up a Python dev container. It's nice and easy to do. So I'll just check and see whether we've got Python installed. So this is now on, this is talking to my Windows subsystem for Linux at the moment. There's no Python installed on there. So I will go and say, add a development container configuration file. And it will come up with a huge list of different pre-configured environments for me that are all sitting on a GitHub repo somewhere. So you can go and browse those yourself if you want to. But I'm going to pick a Python one. Let's pick Python 3. I'm just going to, which version of Python do I want? Do I want Node installed? No, I don't need it. Do I want all these other things installed? I don't need any of those. I just want a bare bones Python environment. And I immediately get the option to reopen that in a container, which I will do. Now, it will only take probably, 5 seconds here. And I'll be honest, if you haven't ever spun up a Python container before, so the images need to be downloaded, it will take a minute or two to do this. But this will be pretty quick because I have, the way Docker works with all the different layers, I'll have those layers already on my machine. And now we're inside the container, we're connected to the dev container, and we should have Python installed, and it's Python 3.10.2. What do you need to make this work? Well, you need Docker. It's a dependency on Docker. I think I'm just going to do a Docker PS to show that one's running. So we've got a different container now running on Docker. So you need Docker. You need an extension in Visual Studio Code. So it's the remote, is it remote containers extension it's called? Basically, if you install the remote development extension, it pulls in the remote SSH, remote WSL, remote dev containers packages. I think there's a remote SSH as well. So it pulls in all the remoting packages. And you need a couple of files. You need a Docker file that describes the Docker, the container image that you're going to build. So it's pulling that from the Microsoft Container Registry. There's nothing magic in there. And you need this devcontainer.json file that tells Visual Studio Code kind of what the configuration of this container is. So which Docker file am I going to use? And how do I want my VS Code environment customized so I can configure settings within VS Code in this dev container file, and I can configure the extensions that are installed as well within this dev container file. So if I share this file with other people, if I push this to my GitHub repo, which is what I would do, then anybody that does a clone of that repo and accepts the reopening container will get exactly the same environment that I have. It is fantastic. Now the question is, it has finished, good. Okay, so GitHub Codespaces is essentially that same technology, but rather than running locally on my desktop, it's hosted in GitHub for me. So I get a, as they would describe it, blazingly fast development environment on GitHub by simply clicking the Open in Codespace button. And it is blazingly fast, to be fair to them, especially if you choose one of the larger ones. It's not free. You do have to pay for this service, but it's effectively the kind of the moving of that dev containers technology into GitHub. So we're in the same repo again, but rather than being on my desktop now, so we're in the GitHub website, I can just click on that ubiquitous space lamp code space, and it will spin up that container on a VM somewhere in GitHub's server farms, wherever they are. And I now have, this is Visual Studio Code in the browser, talking to that code space, which is exactly the same environment we were looking at on my desktop. I'm not entirely sure what I'm rooting around for here, but I was doing something important. Oh, I was looking for the open a new terminal because the terminal wasn't open. So we'll just do the same thing again, show that we've got. So because we're in the container running on GitHub, I can still do func start or SWA to run this application. It's exactly the same environment. And what is particularly clever about it is if I start debugging, which I think I've just done, that application is now running at a local port on that container, which is in GitHub somewhere. I can connect to that on my local machine because they've done some clever port forwarding for me. So that URL gets forwarded to that port on that container running somewhere in GitHub's server farm. So I can debug it like any other application, even though I don't have local access to some of the URLs that are being generated by things like the static web apps emulator. I can debug the node stuff as well. So this is Azure Function. It's looking for a particular signature on this is actually the solution I talked about earlier that runs the CI/CD pipeline when I deploy the marketplace instance. You attach a signature to that. I've got a little test here that's going to post a signature of 123, which is not the signature that it's looking for. But again, I can send that request. And I've got a breakpoint in my Azure function that just on the line compares the actual signature with the expected signature. So I'm looking for a GUID, and I've got 123, so not surprisingly, that's not going to match. It's going to fail and return a 400 code. If we continue, and up there we've got 400 bad request. And that's using that test.html or HTML, what we call it, is using another extension in Visual Studio Code that's a kind of lightweight mechanism for sending GET post requests, calling APIs, etc. It's very cool. I don't have to just take the pre-configured code space. I can configure it to my liking. So for example, I might want my code space on a different branch. I might not want it on main. I might want a different dev container configuration file. I might want a bigger machine. I might not want it in West Europe. I might want it somewhere else. So I can configure that, that code space. As I say, it's not free. You have to buy access to code space because it's effectively running VMs in the back end. It's no great surprise. But it does give you the ability to just go to a GitHub repo and click on code space, and you're up and running within seconds of within that repo. Has anybody played with Copilot? One or two folks? Okay. I was a huge skeptic. I guess I still am a bit skeptical, but I was a huge skeptic of this, so I thought I'd have a play around with it. Copilot is an AI pair programmer. So it is looking across they have looked across billions and billions of lines of code in order to train this algorithm to try and determine your intent, what it is you're trying to do, and then write the code for you to do that. So if you haven't played with it, I think you might have missed your opportunity to play with it, because I think it's out of preview and it's now gone GA. And again, this is something that is a paid service. You'll see in the bottom right-hand corner, I'll just walk across quickly, this little guy here spins every now and again. That's Copilot thinking about what it wants to do. I should point out that the gray stuff is all stuff that Copilot is generating. So I'm not typing these things. This is Copilot that's generating that, and all I'm doing is hitting tab to accept it, or in that case, delete to line it up. So I am typing there. That's me just typing a comment, and then it even suggests how I might want to finish the comment before it then suggests how I want to implement the code. Now, I had to prompt it here because it didn't start with an assert, so I've given it the beginnings of that, and then it's prompted me with a whole bunch of different asserts, which I was quite pleased with. And then print statement, and then suggested how I might call that unit test. That's quite cool. So we'll run that after I've just resized the terminal window slightly. We'll cause that to run and see if that works. Very nice. All tests passed. I'll sabotage one of my tests just in a super quick, ugly way, and just confirm that it now fails. And we get an assertion error. So that was to me, that was quite interesting. But it was kind of what I expected. I'd seen that done, if you like, with Copilot with people before. People had published demos of that before. Yeah, I thought, well, what if I can figure out for numbers prime? What about if I want to find prime numbers in a given range? Again, it's generated all this code for me. I can then ask, okay, it's prompted me for numbers up to 100. We can run that. We'll get the primes up to 100, and obviously, it's just like, now it's not, I'll make two comments on this. One is, it's not perfect. You do have to, there's no guarantees. You do have to check the code that's been generated. The second thing is, this was the main reason I pre-recorded these demos, because it is unpredictable. It doesn't always give you the same suggestion. You can you can choose. There's a keystroke you can bring up that will open a window that shows you the 10 top suggestions and pick one. But if some of those suggestions are of equal weighting, you get different ones each time, and that's really difficult to demo if you don't know what's likely to happen. So, hence pre-recording this. Also, I was going to lose my access to Copilot at the beginning of October, which wasn't good timing for this, because that's when it went GA. Turns out they very kindly let me keep it, but I didn't expect to be keeping it. I thought I'd try something more difficult. This is a Jupyter notebook, commonly used by data scientists. I didn't really expect this to work. And I'm looking at the Iris dataset, which is, again, is a very certainly common dataset in the Microsoft world if you're playing around with machine learning and the like. And I thought I would see if it could help me train a machine learning model, because I certainly do not know how to do this. So I've loaded the Iris dataset based on all I did was type a comment, and it's done that for me. I then said, okay, I'd like to look at the Iris dataset. It did that. I'd quite like to know what the Iris dataset looks like. So remember, I'm only typing a bit of a comment, in fact. So I can see that it's got 150, it's got 4 parameters, if you like. It's got 150 of each, examples of each of these irises. I can see the mean, the standard deviation, etc. All very interesting. What about if I wanted to see the data? Again, I don't know how to do this. I don't even know what SNS pair plot is. But it's going to do that for me. And it's going to do that in actually a very, very nice way. So it's plotted each of those parameters against each other so you can see the clustering of the different species of iris. And that's kind of exactly what I would have liked to have seen had I known how to achieve that. So now I'm kind of meandering down a path of I'm not entirely sure what I'm doing. This is really Copilot taking me down a scenario. And I don't know if this is right or not, but we plotted 2 of those particular parameters against each other. And we can see that the blue was that the setosa is quite well separated. The versicolor and virginica are quite kind of intermixed. But we want to try and train a machine learning model that can identify the species of iris based on the sepal length and the sepal width. I am out of my depth at this point. I'm just letting it do its thing. But it does do some clever things. So the first thing it knows to do is that you have to drop axis 1 from the input set, because axis 1 is the answer. And if you provide the answer to a machine learning algorithm, I mean, you have to train it on that, but you can't provide that to the test data set. So you separate the answer from the input values, so the sepal length, sepal width, etc., and what species gets pulled out. You then split your data set because you need a certain amount of data to train it and a certain amount of data to test it. So it's done that for me. And then it's gone off and picked a k-neighbors classifier to train for me. And it's done that. And at that point, I was a bit stuck because I didn't know. I don't know whether that's useful or not. I don't know if it's any good. Tell me. You can see I'm fumbling here because I'm trying to describe what I want to know, which is how good is this? Have I trained a model that is any good at determining the iris, or predicting an iris based on the sepal length and sepal width? So I've said, okay, assess the model, and it suggested with a confusion matrix. That rang a bell from a couple of years ago when I played about with this stuff. And it's given me a confusion matrix. It actually shows on this very small data set, it's perfect because a confusion matrix shows for an input type of type A, how many of them did you correctly predict, or did you incorrectly predict type B, type C? And for type B, it kind of shows where you predicted a particular type. So that's perfect, but it is a very small and relatively easy data set. But that's certainly something I could never have done on my own without looking up documentation, Stack Overflow. And I think this is kind of what Copilot is going after. It's those scenarios where you kind of know how to do it, but it's a lot easier to go and find an existing implementation. Copilot is going to go and scan those things and bring them in. So for boilerplate code, I'm kind of converted that this could be really useful if treated with a little bit of care, and you don't just willingly accept every suggestion that it gives. So, last thing, security. I said GitHub had made big investments in the security space, and GitHub Advanced Security, they describe it all the time. This is a repo that I have forked from something called Juice Shop. It is from OWASP, the Open Web Application Security Project. I can never remember what that acronym stands for. But you'll be familiar with the OWASP Top 10, same organization. They have produced an intentionally vulnerable application for you to test out code scanning tools and the like. So I forked it into GitHub. And the first thing I did was went to Insights Dependency Graph. So this allows me to explore all the dependencies in my repo. And so in this case, package.json, front-end package.json. It's even got dependencies in my workflows for my CI workflow. So it's looking to all the external dependencies and walking that tree and allowing me then to explore those things. So Istanbul.js relies on Istanbul.js schema, and that relies on conventional changelog, standard version, etc. So I can just keep drilling down into those dependencies. And it gets kind of scary when you realize how many dependencies there are. Now, I overlooked the fact that there was a big banner at the top saying you have vulnerable dependencies. and those ones are highlighted in kind of green as well. It's also on the front page of the repo. That's called Dependabot, and Dependabot is sitting there watching for new vulnerabilities that are flagged against these kind of frameworks and dependencies in your repo. And then, for any vulnerabilities it finds, it will give you a report that you can drill into. So in this case, we've got a command injection vulnerability, and it will give you a recommendation. So it will pull this from the vulnerability database, give you a description of the vulnerability, and give you a recommended action. In this case, you're out of luck. You're going to have to use something else. But for example, in this case, we've got a dependency on an older version of JSON Web Token, and we can update that, which is hopefully a less painful process. And those are front and center when you go into that repo to say you have a vulnerability in one of your dependencies. Where am I going next? Code scanning, maybe? Code scanning. So there is a workflow in this repo that I added for doing GitHub code scanning. So every time the solution is updated, anytime we do a push or we accept a pull request, it will run the code scanner, which is looking for common vulnerability patterns in the application code itself. Here we've got some hard-coded credentials. Actually, it picked up quite a few of those. So there's a bearer token that's been hard-coded there. But it will pick up much more sophisticated vulnerabilities than that. I don't know if I drill into any of the other ones. But any time a commit is made, that's going to run. I think it's only in GitHub Enterprise now, there is also the ability to prevent a commit. So it will do a pre-scan before the commit is made, rather than doing a scan once the commit is done and then alerting you to the presence of the vulnerability. And then I think the final thing I'm going to mention, because I can't demonstrate it. So we looked at, this is just within the settings, you can, depending on whether you're in a public repo, whether you're on GitHub Enterprise or not, depending on your configuration, some of these things you can switch on and off and configure. But we've got dependency graph, which you saw right at the beginning, Dependabot for alerting, code scanning, and secret scanning is the last one I just want to mention. I can't show this because I'm in a public repo. It is enabled on all public repos, so it's looking for connection strings, SAS tokens and the like, but you don't get alerted of the issue that gets alerted back to the provider of the token. So in this case, actually I'm not sure I embedded one in here, but when I, for example, put a SAS token in, it will tell Microsoft that that's been compromised, and it's up to Microsoft to take whatever action they choose as the partner, or the GitHub partner. It's not just Microsoft, there's lots of partners signed up for this, whose secret has been compromised. On GitHub Enterprise, you can configure this to do whatever you want, alert you, you configure your own secret patterns to be able to pick up other types of secret, etc. So that's all I wanted to say, really. I'll just leave you with the thought that we have a tremendous history in the development space. Our tools and platform has been trusted for decades. Yes, we have the choice. We've got Azure DevOps, we've got GitHub. More and more you will see the learnings from each come through in each other. Don't be surprised when you see a lot of noise around GitHub and a lot of the innovation going into GitHub, because we're trying to bring some of that enterprise knowledge and capability into the GitHub platform. Azure DevOps is still a first-class citizen and will be around for many, many, many years to come. With that, I want to say thank you very much for listening to me. I hope you got something out of it, and enjoy the rest of your day.